Good afternoon, everybody. So today I have the class on nitrines. Okay, nitrines are almost similar with carbons we have discussed earlier. So nitrines are monovalent species analogous to carbons. They can have, like carbons, they can have two types of, say like singlet and triplet like this. So nitrines are monovalent species like this. Okay, we can write this way, or Rn like this. So they can have two types like carbons. They can have two types of nitrines. You can have there are two types of nitrines. So they are monovalent. Only one valency like the R, linked with the R. Monovalent species and SARS, highly reactive intermediates. Okay. So they have, like carbons, they can have two types, singlet nitrines, and another one is a triplet nitrines. Okay. So triplet nitrines, singlet nitrines, we can write this way. The structure is, say, R, like this one. Okay. So here one of the this here in the case of singlet, the one is a pair like this, but in the case of triplet, the unpaired one put up, okay, and it's parallel, and they are here is pair. This is singlet and it is triplet. So you can write the structure of this like this. This is the empty one, and this is sp2. Okay, here both are pair. Okay, like this. This is singlet empty, 2pz orbital. Okay, you can say orbital, atomic orbital. And this is for singlet. So here sp2 bonds are here paired. And in the case of triplet, you can have structure is like this. So one here sp2, here you can occupy one here. Here pairing. Okay. So where one sp2 is occupied by only one electron, and in the case of empty 2pz orbital also occupied by only one electron. Okay. So the difference between this, that I'm repeating again, that nitrines have two types. One is singlet, another one is triplet. In the case of singlet, both electrons are paired, but here they are parallel. Okay, so this is the difference between singlet and nitrines. So they are almost similar with, like we have discussed earlier in the case of carbon, similar. So now let's come to the generation of nitrines. Okay, nitrines can be generated like carbons. You can have two types. So let us have generation of nitrines. Generation of nitrines. So there are mainly two types of methods for generation of carbons. First one is alpha elimination, from alpha eliminations. From alpha elimination, or you can say by alpha elimination. This is one alpha elimination is one elimination. Okay, elimination. That is both the living groups, that means attacking both two atoms or groups. Two groups are removed from the same atom. Okay, so for example, say generally you can have this way R, let's say NH. Okay, another one living. This is, let's say, living group. So let's say take some base or some nucleophile. I take this one, and this will give. So first will give a charge will be given here. So you can have this, and then living group. Then the living group is lost, so it becomes, this charge is given here, so it becomes negative charge. So now this living group is lost, it has taken the charge also. So then you have this, okay, like this nitrogen and negative charge. So this way, so two atoms or groups are removed from the same nitrogen atom. So this is the, by alpha eliminations, we can have this type of elimination. Because like earlier, carbon also same case, alpha elimination can have get like this. For example, one example is, say for example, CH3, and or you can have good living group like OSO2, here sulfonic group. So here also same case by reacting with some base like ethoxide, OET, sodium ethoxide or like this. So first step is pick up the proton, ethanol gives ethanol. So you can have, and then this is negative charge now, OSO2. So it gives negative charge. Then lost this one, the negative charge is taken by this sulfur ion. So it gives this nitrogen, okay. So here OSO2, here negative charge. So in this way, so by lodging two atoms or groups from same atom, nitrogen atom, we can have this nitrogen. So by alpha, pass one for generation nitrogen is by alpha elimination. So next, second one we can have. That's why second one we have, say, from certain double bond compounds. Nitrogen can also be obtained from certain double bond compounds by fission, or okay, you can say by fission or by pyrolysis, or you can say by pyrolysis or by fission of photolysis, by pyrolysis, by heating, okay, or by photolysis of certain double bond compounds, double bond compounds, but just like earlier cases, in the case of carbon also like this. So like, for example, I'm giving, for example, this ethoxide, carboethoxy, azides, okay, azides are like this, negative charge here and positive charge here, okay, the azide, from azide, so this you have certain double bond compounds are here. So by heating or light, by heat or light, by pyrolysis or by photolysis, so you can get this way. This kind of certain method you can have this way, you can have, okay. So you can have this, then you can get an CO2, then you have this, okay, this nitrogen, carboethoxy, nitrogen, okay, this is very reactive nitrogen, okay. Then you got plus nitrogen. So this is the one way for generation of nitrogens. Second method by pyrolysis or photolysis of certain double bond compounds. Even isocyanates also can be have. If another example is from isocyanates. From isocyanates you can have, and the C double one isocyanates. By heating or by pyrolysis, you can have by heating or by photolysis, you can have this also. So like this, you can have then this way. So you can have this nitrogen, simple nitrogen, you can have plus this carbon monoxide. Carbon monoxide, positive charge, negative value, you can just CO. So here oxygen lost electrons, so it becomes positive charge, and it gives carbon becomes negative charge. So this is carbon monoxide. So you can have this nitrogen can be generated another way. So this is a second method for certain double bond compounds by pyrolysis or by heating or by pyrolysis or photolysis of certain double bond compounds. Nitrogen can also be obtained. Even another example is from certain cyclic compounds like triple cyclic compounds. You can have also nitrogens. Third one is from certain double cyclic compounds. From nitrogen can be also generated from certain cyclic compounds. Okay. Cyclic compounds. So for example, say you can have oxyridines, the tricyclic compounds. So they say like oxyridines. So here, some substituents here, phenyl. Here also phenyl. Okay. Then here you can have another phenyl. There's another hydrogen here. No, not here. This side here, hydrogen here. Okay. So this compound can say oxyridine. Aziridine. Okay. The aziridine compounds having oxygen here, so we can have oxide. So this by pyrolysis or by heating or by photolysis, say by heating or by photolysis, you can have these certain compounds can get this C-double-bond-O will come. This will go this way, and this will go like this. So here you can have hydrogen here, phenyl here, benzaldehyde will go off, and plus this nitrogen. Okay, so nitrogen. So in this way, you can have generated this nitrogens can be generated. I'm repeating again, nitrogens can be generated by three methods. First one is by 1,1 elimination or by alpha eliminations, and second one is from certain double bond compounds, and third one is from certain cyclic compounds. So this is about the generation of nitrogens. Now let us come to generate this about the reactions of nitrogens. Okay, reactions of nitrogens. So similar with like carbons, nitrogen also can be undergo many reactions. First one is, let us discuss. First one is CH insertion reactions. So this nitrogen can be inserted between the CH bonds. Okay. The second one is addition, or you can say formation of aziridines. Formation of aziridines. Or you can say addition of nitrogens to double bonds, nitrogens to olefinic compounds or double bond compounds, olefinic compounds. Okay. So like carbons, you can have two types. You can generally these two types of reactions can be discussed. First one is carbon hydrogen insertion of these nitrogens to the carbon hydrogen bonds, and second one is formation of aziridine. This is similar with addition of nitrogens to double bond compounds. So let's discuss one by one. Okay, first one is CH insertion reactions. Insertion of nitrogens to the carbon hydrogen. First one is insertion of nitrogens, or you can say nitrogen atoms to CH bonds. So this is the first one. So here CH bonds, insertion into CH bonds are observed, especially carbonic compounds like nitrogens, like this type of nitrogens, like and CO and Z. These nitrogens can be used as nitrogens. So like Z can be either alkyl or aryl, like this, alkyl, aryl, or hydrogen like this. So it can be attacked. Even alkoxy also. If that is alkoxy, then you can say if the alkoxy group, then we can have this nitrogens can be have inserted into this. So here, if alkyl group added the CH bond, inserted CH bond, then we can have the reaction. We can have amides can be obtained. So by if the CH bond or like this. So when nitrogens are inserted here, then between these two carbon, so like this we can get C. Okay, this or nitrogen will be inserted here. So CH, NH, and COZ. Okay. So product will be like this. So here nitrogens can attack. This nitrogen attack is inserted in between this carbon hydrogen bond. So in between carbon hydrogen bond, the nitrogen is inserted, and nitrogen atom is inserted. So when there is alkyl, aryl, or hydrogen, we can have you can have this amides. Okay, we go to amides from here. You go to amides. But if you use alkoxy group, here is alkoxy group, then you got this carbamates. Okay, carbamates are of 10. So suppose it's alkoxy group like OR or alkoxy group. And be simple R is like R, then you can have amides. Okay. So we'll just discuss this thing one by one. Okay. First one, let's see insertion of nitrogen atom to carbon hydrogen bond, insertion reactions of CH, insertion reaction of. Let's see the mechanism how it is inserted into this one, to carbon hydrogen bonds. Okay, first one. So let us say yes, R. Okay, let's just see principal compound RS. Okay, RS. This is carbon. Here R is alkyl benzyl. So first step is this. This is like C. Okay. So first step is reaction with let's say carbetoxy-nitrines. Okay, carbetoxy-nitrines are used. Let's say this carbetoxy-nitrines, CO. Now Z. Okay, carbetoxy or these nitrines. So mostly this here because singlet nitrines are used. In this case, only singlet nitrines. These singlet nitrines are used. So here first step is it can be concerted mechanism, can have this one and this go like this. So in between this nitrogen will come and this will take up the hydrogen here and then this CO Z. Okay. So it is a concerted mechanism. So first we can have mechanism. First one is inserted mechanism. So it can take place in another way also. Say you can have plus this another mechanism is say you can have to the intermediate. So first say hydrogen here and then nitrogen, and then you can have CO Z. Okay. So these are the intermediate forms. Then finally loss of this bond loss. So you can have this is lost and then you can have this compound. Okay. So this is two types reaction that can be like this. So through the intermediate reaction also can take place. So what I wanted is reaction of nitrogens can undergo by insertion, CH insertions, where nitrogen atoms are inserted between the carbon and hydrogen bonds. So I'm giving the mechanism here, one example. So like this. Nitrogen attack here, concerted mechanism, so you got this combined. So if there is alkyl group or allyl group, then we have the amides. If there is an alkoxy group, we got a carbamates. So this is about the reactions of nitrogens by insertion, CH insertion. Now the second one is addition reactions, formation of aziridines. Okay, formation of aziridine formation. Second one is aziridine formation. So it takes place by addition of nitrogens to addition to carbon double bonds. Okay, the olefinic compounds. So nitrogens can add to carbon double bonds, olefinic compounds, to give aziridines. Okay, so you can have like earlier carbons type. We can have discussed two types of reactions here also. So here you can have first one. You can have singlet by using singlet nitrogen. Singlet nitrogen like carbon, singlet carbon. So you can add to double bonds, CH double bonds. Only by giving only stereospecific compound, only giving one specific, it is very specific, giving one stereospecific compound, that means cis will give cis and trans will give trans. So let's say, for example, the earlier cases, so let's say cis, okay, cis olefinic compound cis, say RR or cis3, cis 2-butene, okay, reaction with cis 2-butene, this is cis compounds, cis 2-butene reacts with, like, let's say this nitrogen. Okay, so here singlet, borax singlet, so you can have attack here, so you can have, so formation is this NR and then C, and this is, you can have this methyl group CH3 are here, so this is hydrogen, there are C's, you're going to cis aziridine. Okay, cis aziridine. So here reactions take by giving only one cis will give cis aziridine, cis 2-butene will give cis aziridine, and like suppose we have trans, say like trans CH3 here and here. So yeah, like attack with nitrogen, then you can have nitrogen. So you can have here also, you can get a product will be, this will be trans. Okay, so here C, then here CH3, here hydrogen, then here nitrogen atom as in ring. So we have hydrogen, and this we have, and the CH3 here, and this hydrogen here. Okay, so here trans product, this trans aziridine. So what I want to say that if you use a single nitrogens, addition of single nitrogens to carbon-carbon double bonds, will give cis olefinic compounds will give cis aziridine, and trans olefinic compounds will give trans aziridine. So what I want to check is that the formation of aziridines here is stereospecific, giving only one product. Cis will give cis, trans will give trans. So this mechanism is by two nitrogen. Okay. Another mechanism will have single nitrogen also can have added to by 1/3 dipolar addition. So you can have also another one is nitrogen here, nitrogen approach. Okay, first one is nitrogen approach. Now we can have second one is, first one is nitrogen approach through nitrogen. So now we can have another mechanism by 1/3 dipolar 1/3 dipolar addition. By 1/3 dipolar addition. Here mostly a cyclic intermediate is formed called triazolines. Say for example, say let's cis, earlier one cis to butene inserted with this dipolar compound, try 1/3 dipolar. Let's have, okay, let's this one OA negative charge, and here this is O negative charge, and let's say R here or something, R. Okay, so it becomes negative charge, positive charge, negative charge. So this is 1/3 dipolar compounds you can have. Yeah. Okay, this way. 1/3. Okay, 1, 2, 3. So 1/3 dipolar compounds can also attack. Yeah, so here, similarly like earlier case, this attack here, and this one will come, and this one will come here, and then we get this way. Okay, so we got a, or you can have this another way also. So 1, 2, 3, 4 compound. We can have another way also. You can have this one. Then you can have this way. First this one. Okay. Or you can have this also. You can have this one. You can write this another way. This you can have product. Another example is by reacting with CH3 and CH3. So another one, azide with that reaction with the azide also can take place. Azide, the azides are like this, and so here positive charge and negative charge. Here azide, reaction with the azide. So you can have cyclic intermediate here also. Cyclic intermediate will form. So it gives this will attack here, first will attack, then this will attack here, and this will give this. So here similar with oxygen attack here, and so it can be removed. So you can have first I write here, okay, CH3, so you can have 5 member ring, and then CH3, so here N here, then we can have N here, so here this will be double bond here, this will be R here, okay. So this is we call it cyclic compound intermediate form, triazolene is forms. Two triazolines can be converted to. So you can, and then lost this one. This way, attack here, and lost this one. So you got a product, C's product, this azidine form, CIs, and R here, CIs, and the R CH3 here. Okay, so we got this CH3, azidine is formed. I think you can see this one. Okay, so azide reacts with Cs 1 to butene, Cs to butene will get this Cs compound. Okay, Cs azidine compound. So here, of course, you can have similarly you can write this also, but this is very mostly azides are formed, but this is not forming. Okay, you can write the mechanism, but not lost. So you can try this also. Okay. So what I want to say, nitrenes azidine compound can be formed by addition to other. In the case of single nitrenes can attack the double bond compounds in two ways, by nitrene approach, and otherwise is 1,3 dipolar additions through formation of triazolene intermediate. So this is about the addition by singlet nitrenes. Okay, so almost similar with singlet carbons. So now let us have using the addition of triplet nitrenes to carbon-carbon double bonds. Sorry, here triplet nitrenes. So here in the case of triplet nitrenes, so these are both are parallel. Okay, both are parallel. So you can have R here, both are parallel. Okay, so here. This is triple nitrene. So in the case of triple nitrene, it is a big difference from the addition by single nitrene. So here, first is formation. Suppose a Cs will give both a trans or and as well as cis products. So Cs is a Cs. Okay, Cs butene. Okay, CH3 butene reaction with triplet nitrene. Triplet. So you can have this way. Triplet nitrene. Okay. So triplet nitrene, it can attack. First, it can attack this formation. First attack. In the case of attack to the pairing will take by Hund's rule. So you can pairing take like we have discussed in the earlier in case of carbon also we have discussed this thing. So here they have one can for a pairing. One is up. One is down. Okay, here double bonds are like this. So this is why we can bond formation takes place. So here one down, one up, and one down. So you can combine one up and combine with down. So by Hund's rules, so the past formation is CIs, methyl, C methyl. Okay. So you get the hydrogen here. So past residues is off. So you can get, and now we have another of, okay, and R. Okay. So this, so one down with replace with let's say we can have this one up, but you combine these two, or you can write this way also. One should be up, also be down, and this is another one is up. Okay, now we have up. Down, this is up combined with this down one, so you can do this way. Bond is from here. Now this bond for this compound can undergo by some type of rotations or collisions. Right? Collisions takes place. Collision. So ISC intersystem crossing. by photolysis, by heating, by photolysis you can go, and this kind some rotation of the ring takes place, so the rotation of the bond takes place. So in this case we can have, so this intermediate can undergo some types of collisions by intersystem crossing, and then formation of this rotation takes place, so followed by rotation of the ring bond, rotation of the bond takes place. So we can have, so first when this will come, you can write this way, this dot 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 is also dot dot dot. Okay, this is Broadway. Okay, so now after say collisions, so you can have these two types. Now you can have this hydrogen and this methyl CH3, and then this hydrogen and this is methyl group. Okay, so you can, I think you can see this one. Okay, so first this up will come, this is up, so now this will come, this nitrogen, this will be collision by come to down. Okay, this is down here, let us write here. Okay, so now can pair this down electron will come to the up down, so this you can combine. Another one is you can have this way, another one by rotation of the ring, our rotation of the bond, you can have CH3 methyl group here. This is, so rotation you can from CH3 will come here, and this hydrogen will come here. Okay, by rotation. So similarly you can have same case. Okay, so you can write this way here also, no problem here also. Okay, so then combine these two, you can have a ring formation takes place. So from here you can seize, from here you can transfer that. So I would like to, I think you can see here. So I write here. So from this, so first I will repeating again. Okay, in the case of addition by triple nitrines to the double bond compounds, cis can give both cis aziridine as well as trans aziridine in the case of triplet. So first step is addition, pairing takes place with the down, with the up, down, with the up, formation of ring takes place. Then by collisions, by light, and then followed by rotations, we can have cis and transform intermediate. So these two intermediates finally undergo ring formation to give the aziridine. Okay, so write down here the products. So this steps is, this will give formation of this hydrogen and NR from this methyl, and this is, and this hydrogen, and this is methyl group. Okay, another from here you can get this hydrogen, and this is methyl, and this methyl CH3. Okay, then you can have NR, then this hydrogen here. Okay, so we got this is trans aziridine, trans and cis. Okay, so what I want to say is that by addition of triple nitrine to carbon double bond will give from cis product, cis will give cis substrate reactants will give both products, cis as well as trans. That means the isomeric mixtures are obtained by addition of triple nitrine to C double bond bonds. But in the case of single nitrine, it gives only one product. So this is about the reactions of nitrines. So you can even nitrines can add to aromatic compounds. Let's say for example, in the nitrine may also add to aromatic rings followed by ring expansion. Say for example, so I write down nitrines. Nitrines can also add to aromatic compounds. So in this case, with the expansion of ring, followed by, you can say followed by expansion of ring, expansion of ring takes place here. So for example, you can have benzene. For example, benzene So let's say benzene. Okay, simply reacts with the nitrogens. So we can have the first step is formation of aziridine, like earlier cases, addition of nitrogens to double bond compounds. So we got a formation of 3-member ring. So here NR. Okay, now we have this one. Then this can be undergo expansion of the ring. So the ring can be expanded this way. Okay, so we got 6-member rings. We'll give 7-member rings. 7-member rings. So you can have this way the product like this. So what I want to say here is that nitrogens can also add to certain aromatic compounds, aromatic ring, followed by ring expansion of the ring. Expansion takes place. So here, these nitrogens attack to the benzenes. We got a N-carbotoxy. You should say N-carbotoxy. Azipine. The reaction is separate ring compound. So you can be see N-carbotoxy. We switch R is CO2 ET. If R is equal to CO2 ET, then you can say N-carbotoxy. It's very common. Okay, carbotoxy, azipine. For the formation of the photosynthesis of azipine, this is one of the reactions for formation of the corn. Another example said when pyrrole also can add to this one. I will write another example. Pembering, nitrogen pembering can also add to this one. So like this. NS. Okay, so you can add with a carbotoxy or let's say and CO2 ET. This is nitrogen. Okay, this is nitrogen. So first double bond compounds attack this one, right? So you got this aziridine formation takes place. NS. So here and CO2 ET and CO2 ET. Okay. So first formation is aziridine compound, aziridine cyclic, aziridine is formed. So now we can have these two methods. Here first is another one is 1,4 addition takes place. This is 1,2 addition, 1,2. You can have 1, 2, 3, 4. One you can have another addition can take place by 1,4 addition take place. So here another attack here like this. So you can have you can write. So you take here, okay, and is, so you can write addition takes place here, and CO2 ET. Okay, so you have hydrogen here, this hydrogen are here, hydrogen are here, so here. In this way, nitrogen can attack, let's say carbotoxy like this. So here attack here. So in this way. Okay. So addition 1, 2, 3, 4. So this is 1,4 addition and this is 1,2 addition. So what I'm telling that in the case of 1,2 addition, you double bond here. In the case of 1,4 addition, you take like this. You take here. Okay, formation like this. So we got two products are formed. So if you lose this one, this hydrogen are here, hydrogen here, you can get two products. So if you lost this one, hydrogen you lost. So here you can lose the hydrogen. Okay. From here you can try this one and this one. This is lost. So you form a negative charge here. So you get it. And is double one here and double one here, and then the hydrogen here, then a negative charge here. Hydrogen here, okay. Then CO2, let's say R. So this pick up this positive charge now. So this pick up this one. The hydrogen is pick up. So it comes NH here. It comes like this. So the product will be, this product will be. So how will come this product will give this one. This okay. So you get to start here. So you can be, this is double bond here, I think. This is here. Okay. Like this is not. It's okay now. You've got double bond here. This double bond here. So now this pick up the proton, then the NAs, and this will go like this. Now you can have this way. Or you can put this one, proton is pick up this one. Or you can have this way and this one, NAs. Okay, the mechanism like this. So pick up the proton from here. So double bond will from here and double bond from here. So final product will be NAs. So NAs are okay. Addition takes place. This is our one product. So in the case of second one for addition, you get different product. Okay. So here we can have this hydrogen here, this one here, and this is broken down here. So the hydrogen transferred to Na. So product will be here. Product will be different here. NH2 here. This will be NH2. So the hydrogen is transferred to here, and this will be intact CO2 So we have the different types of prime embodiments, where one is NH, one is NCO2. So this is about the addition of nitrates to carbon double bond. So here I'm thinking about this. The nitrates can also add to certain aromatic compounds, followed by ring expansion or by rearrangement. Here in the case of benzene we got a ring expansion. In the case of here in the second compound we have got a rearrangement takes place. So this is about the reactions of nitrates